So here I have created a user guide for NVIDIA's MIG, which is multi-instance GPU. It is used to slice GPUs into smaller chunks. So recently I had to deal with NVIDIA's MIG, so I documented everything I did by writing some text and taking the screenshots of all the work that I did, and I have compiled everything into this user guide. So before starting, let me just tell you what GPU slicing means. So you have a NVIDIA H200 GPU. NVL here basically just means NVLink. NVLink is a technology by which two NVIDIA GPUs can talk to each other using high bandwidth, or in simpler terms, in a high transfer with a high transfer rate. So an NVIDIA H200 GPU has 141 GB of VRAM. But let's say you have a task that does not require so much of VRAM or compute. So what you could do is you could create a tiny section. You can slice that GPU. Let's say you only want 10% of the GPU's power. So you can exactly create a slice which has 10% of the GPU's power, and then you can use it for your own programs or your models, and the 90% of the GPU is still remaining, and you can run separate workloads on that. So what what's the advantage in this scenario is that, let's say if you're running a small program, your entire GPU won't be hogged up, and you will be able to run many other workloads that you have. So there are two types of GPU slicing that NVIDIA offers. One is MIG, multi-instance GPU, that we are going to discuss now. So MIG slices the GPU on the hardware level. We are going to go deeper into what this hardware level essentially means further down in the video. And the other type of slicing that NVIDIA provides is temporal slicing. So temporal slicing basically means is that what it means is that, let's say you are trying to train a model on the NVIDIA H200 GPU. You're training two models, and both the models wants to access the same GPU. So basically, a small amount of processing time is given to each model. Like, let's say 10 milliseconds, 10 milliseconds to model 1, 10 milliseconds to model 2, and it fluctuates rapidly. Model 1, model 2, model 1, model 2. So GPU gives its compute time to model 1 and model 2 for a very small amount of time, which is known as a time quantum, and it switches rapidly between them. So while training, it almost feels like the GPU has been divided into two, hence why the two models are able to use it. But it's the same GPU, it's just that it is alternating its processing time between two models so rapidly so that it feels like one GPU, right? One GPU which is able to cater to both the models. So coming back to MIG. So in MIG, you have two concepts that you need to know. One is a GPU instance, and one is a compute instance. So there, let me first tell you, you can imagine NVIDIA H200 GPUs having 7 parts. Basically, you can only create 7 slices of this GPU. Now, why only 7 slices? This is a hardware level restriction, because the thing is, the slices that we create are enforced on a hardware level. So you can't change it on your own whims. So there are a total seven times you can slice the NVIDIA H200 GPU. The total 7 slices you can get. So each slice of the GPU is known as a GPU instance. So let's say out of the 7 slices of the GPU, you only need 3 slices for your task. But after you get your GPU slice or the GPU instance, you directly cannot run your workloads or your programs on it. You also need a compute instance on top of it. So to simplify this, a compute instance is like a worker that works on the GPU instance. So we create a GI, that is GPU instance, and on top of not on top of that, inside the GPU instance, we create a compute instance. And the compute instance is responsible for accessing the resources of the GPU instance and running the workload. So yeah, let's take an example here. So here, yeah, 2G basically means how many GPU slices. Here there are two slices, and both these GPU slices have a shared memory pool of 35 GB VRAM, right? And once you have allocated these two GPU slices, you cannot immediately run your programs on this. You need to also use this flag, that is -C, which automatically creates a corresponding compute instance so that you can use this GPU slice immediately. So now let's see how do you first of all enable MIG and what we are going to do with MIG. So here first we are querying whether MIG is enabled or not using this command -I and then some query. Here we can see that the NVIDIA MIG has been disabled, which is disabled by default. So now we need to enable MIG. For that, we are going to set the MIG flag as 1. Here we can see the MIG mode has been enabled, and we are also verifying it using some other command in which we get the output in CSV format. And then you can also use NVIDIA SMI. NVIDIA SMI is basically a command line utility which lets you monitor metrics about your GPU, how much RAM of your GPU is being consumed, how much performance is how much of the processing power is being consumed, what's the fan temperatures and other such metrics. So here you can see that NVIDIA's MIG has been enabled here, and just because we have enabled MIG doesn't mean that we have any MIG devices. For that, we need to explicitly create it. We are going to create it further down in the video. So yeah, as you can see, no MIG devices found and no running processors found. So the GPU is sitting idle. So now you can use the command -lgip. It's an option. So what it basically tells you is that what are the templates that NVIDIA provides you for GPU slicing. So these templates are fixed. You cannot create your own template, but you can definitely mix and match templates, right? So here, let's say I told you there are total 7 slices of an NVIDIA H200 GPU. Here, as you can see, we can create 7 total slices in which each slice, one GPU slice, has 18 GB of VRAM each. So this is one of the configuration in which we can create 7 slices. If we want, we can also create two slices in which each slice will have 71 GB of VRAM. Or if we just want to use the GPU as it is without slicing, you can also you can create this one humongous slice with all 141 GB of VRAM. Here, as you can see, this humongous slice takes up all of the GPU instances available. So there are total 7 GPU instances available, right? Then here, if we come back to the example of we have 7 total GPU instances, and we can, out of the profile ID that is 9, we can create two slices of the GPU which has 3 GPU slices each. We have a total of 7, so it totals up to 6, and 71 plus 71, it almost exhausts the 141 GB mark that we have. Now you may be wondering, like, 3 slices plus 3 slices equals to 6 slices, but we also have one extra slice left. Can we use it? The answer is no, because it is enforced on the hardware level. And if we are using profile 9, from which we can create 2 slices and each slice will have 3 GPU instances, that's the limitation that we have, that last GPU instance slice that we have, it will go to waste. So now what we are going to do is, using the DCI, which is destroy compute instance and destroy GPU instance commands, we are going to destroy the existing instances, the GPU and compute instances, and then we are going to create our own 2 instances. So for that, we are going to use the command -cgi and also use the -c parameter. As I told you, it is required for NVIDIA to automatically create a corresponding compute instance, so that we are able to immediately use this GPU slice. So what is this 9 9? 9 and 9 basically means that we are trying to create 2 slices using the profile ID 9. So let's come back here. So here, as you can see, profile 9 states that we can create maximum of 2 instances. That is why we can only write 9 two times. We can also write 9 one times, which basically means that we are just slicing the GPU once and we are just taking half of the slice, half of the GPU. This slice basically means you're taking half of the GPU, because you almost have half the RAM and half the compute power, right? Your command could also have 5 or 14, 14, 14, because you can use the profile ID 14 3 times, because that's how much the GPU has the capacity to split. Or if you're using this large slice, which is profile ID 0, you can only use it once, because you're allocating the entire GPU's resources at once. So coming back, here was our command, and then we can verify our results in NVIDIA SMI. As you can see here, 2 slices have been created with approximately 71 gigabytes of VRAM in each of these slices. And as you can see, this is the GPU ID and this is the compute instance ID. Still, there are no processors running. And here, this is very important. By using NVIDIA SMI-L, we can get the user ID or the UUID of each of the slices. So let's say you are training a PyTorch model and you want the PyTorch model to run on the first MIG slice. You are going to use the upper UUID, and if you also have like a TensorFlow model and you want it to run in a different GPU slice, then you will use the below GPU UUID. This is very crucial for you to note down these two IDs, because you need to set it while training your model. You need to set on which UUID do you want your model to run. And TensorFlow doesn't is not actually aware about these GPU slices. It will treat this slice as its entire GPU. It's not even aware that there is there is a GPU beyond this. So here we have a training script in Python, sorry, train.py. Here we are setting CODA visible devices is equal to the MIG ID. So this is the MIG ID for the second slice that we have created. So it will only be able to, as you can see, device 0 has been detected, which is the second slice, and it only has a total memory of approximately 75 gigabytes. It is not able to access the entire 141 GB because we have sliced the GPU, and these slices are enforced at a hardware level. So there is no way can our program access the memory from the other slice or access the SMs or streaming multiprocessors from the other slice, right? And here we have a side-by-side comparison of the training happening and the NVIDIA SMI logs. The training is happening on the second slice. As you can see, the second slice has a Python program allocated to it, while the first slice is completely empty. This was just one of the many profiles that NVIDIA has to offer. We use the profile in which we can create two slices of the GPU. There are many other slices which we are going to cover now. So here we are using profile 14, and as I told you, we can create three profile 14s. Which essentially means that you have split your GPU into three parts, and each part has 35 GB of VRAM, and each part also has two GPU instances out of the total 7 GPU instances. And then, yeah, so three slices have been created. As you can see, three separate NVIDIA GPU slices. Then we can also create two 71 GB slices. As you can see here, we are using three GPU instances. We have a total of 7, so we are utilizing 6, and the entire VRAM is being utilized, 141 GB of VRAM. This is the slice that we created initially as well. And we can also use profile 19. Profile 19 is basically the smallest slice or the smallest part of the GPU that you can get. So we are splitting the GPU into 7 parts, and each part has 18 GB of VRAM and one GPU instance out of the 7 available GPU instances. So here you can say that the almost, not even almost, the 100% of the GPU has been utilized if you are using profile 19, because none of the GPU instances are going to waste. And here, as you can see, 7 separate instances have been created. Then we are just repeating our previous GPU slice that we have created. Then we are deleting it. And another thing I forgot to tell you was you can always mix and match these profiles, right? You cannot create your own profile, but you can mix and match profiles. So here, as you can see, we are creating one profile which is has 70. So here we have three slices in total. The first slice has 71 GB of VRAM allocated and 4 GPU instances out of the 7. So even after this we have total 3 available GPU instances. So out of the 3 available GPU instances, we are using this profile, which is again profile number 19, which only takes one GPU instance, and we are allocating 2 such instances. So we are in total we are using a total of 6 GPU instances, and the total of 71 plus 36 GB of VRAM. So almost any permutation and combination works as long as you're not exceeding the total number of GPU instances or the VRAM available. Then we have created the huge monolithic GPU slice, which is you're using the entire GPU along with the 7 GPU instances and 141 GB of VRAM into a single profile. So this is essentially like you haven't even sliced your GPU at all. It's like you have a huge cake, you're taking a knife, you're not slicing the cake, you're eating the cake as is. So here then what I've done is that out of from all of these various slices that I've created according to the various profiles that we have, I've again run the workload that we have in various slices. So this is nothing that we haven't done before. So this was it about how you can create your own NVIDIA MIG slices in the GPU that you have, and how you can run your workload so that they stay on the said GPU slice. I'll be covering more such technologies and creating more such explainer videos on what work I have done. Thanks for watching.